thing we got going on here. Last thing on the list. Last thing we have to find is volume and surface area of spheres. We'll do that today. So, surface area of a sphere. You all have a tennis ball, correct? If you could cut this tennis ball along the seam right here, go ahead and do that for a few seconds with your team. Not cut it, but what would it look like? If you could cut it and open it up, what shape would it make? Go ahead and draw that with your team. All right. How many of you got something either like these two or like these two? Okay? That's kind of what it would look like. Now you'll notice something up here. Surface area of a sphere is 4 pi r squared. What do you see in this formula? 4 pi r squared. What do you see in there that you recognize? Pi r squared, right? Pi r squared. That's the area of a circle. So we need 4 circles. Take a look over here. Could you make 4 circles in these? We could, couldn't we? We'd have 1 right here, correct? 1 right here, 1 right here, and 1 right here. Now, is that covering the entire surface area of our sphere there? No, because we got a little bit of extra stuff hanging on there, don't we? However, if you look at it though, the radius of this circle right here isn't actually covering the full radius of the circle, of the sphere, is it? So, we're a little bit short here, but we got a little bit extra here, and it ends up working out that 4 pi r squared is the surface area of a sphere. So, if you forget, oh gosh, what's the surface area formula? Just think of a baseball or a tennis ball and think, okay, got like a circle here, 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 and here. That kind of makes it up. Now, also, they're going to throw something at you called a great circle. The circumference of a great circle. In geography terms, what would this thing be? Shout it out. 1, 2, 3. Whoa. Equator. This is called an equator. Not as low. Now, if we turn our head sideways and look at it the other way, what would this be? Shout it out. 1, 2, 3. Line of longitude, prime meridian, anything like that. Okay? Line of longitude. That's a great circle. It's going all the way around the sphere, isn't it? With your teammates right now, take about 10, 15 seconds. Find the circumference of that great. Go backwards and find the radius. Go backwards, find the radius of this thing. And as soon as you're done with that, find the surface area of that sphere. Go. Did you get 9 for the radius? Now find the surface area. Go. Yay or nay?
What would it be of time?
Good question.
Is it like 1017?
Yep.
Okay.
1017.8760, blah, blah, blah. So we have this sphere, and we cut it up into all of these pyramids, right? So we have one pyramid right here. Like that. So if we want to find the volume of the sphere, it's going to be the sum of all pyramids. And we just saw that the height of it is actually the radius, correct? So what we really have here is 1/3 area of the base times the height. But the height is actually the radius, correct? So erase that, put the radius. Now that's just for one of them. We've got to add them all up, don't we? 1/3 area of the next one times the radius, plus 1/3 area of the next pyramid base times the radius. And we keep doing that ad nauseum. So you're sick of it. So what we can actually do here is a cool little algebra thing. Do you remember if we have one number that's the same for all of them, we can factor it out? Greatest common factor? We're going to pull out the greatest common factor here. What do all of these have in common? Shout it out. 1, 2, 3. 1/3. What else do they all have in common? 1, 2, 3. The radius, don't they? We're going to pull the 1/3 and the radius out for all of them. 1/3 and the radius. So this is the area of the base for the first one, plus the area of the base for the second one, plus the area of the base for the third one, plus all of those things. All of those bases, though, are these squares, right? But they're all on the outside of the sphere. So what are all these bases? If we add up all these bases, what do they give us? The surface area, right? The surface area of the sphere. So this is really the surface area of the sphere. If only we had a formula for the surface area of a sphere. Wait, we do, don't we? We do! This is exciting. So we're going to come over here, instead of adding up all the bases, which since it's just the surface area, we're going to put 4 pi r squared. And we're going to take this times the 1/3 and the radius. Now, if only you had taken algebra, you would know that you can take r times r squared and get what? Everybody, what is r times r squared? Thank you. Your name is now everybody. R times r squared is r cubed. 4 times 1/3 is 4/3. For those of you who didn't pass middle school. 4/3 pi r cubed. Wait a second. That's how they got this. Pretty nifty, huh? This fam's looking at me like, what? Once again, we got to find the volume of all the pyramids, right? Sum of all the pyramids. That's the sum of every single pyramid, right? So we factored out the 1/3 of the r. So we just have the area of each one of the bases. But all the bases form the surface area. So we just plug in the surface area formula, and then we simplify. All right, take just a few moments, maybe 10, 20 seconds. Find the volume with your team. Go. I believe that's correct. 972 pi? 972 pi cubic meters. Which of the decimals like 3,053 point something? Yes. Now one last thing here. You may have, they may say, okay, you think you're so hot, find the volume of a hemisphere. How do you find the volume of a hemisphere? Take the volume and cut it in half, right? What if they said find the surface area of the hemisphere? Take the surface area, cut it in half, and oh, what about this? Did you find this surface area yet? We're going to have to add that on, aren't we? The 4 pi r squared divided by 2 would find this, but we'd also have to find this area right here, wouldn't we? Okay, that's just a circle, isn't it? Find the area of that circle. So we have the surface area of a sphere, 4 pi r squared. Volume of a sphere, 4 pi r cubed. That's it. Thanks.